Alright, this video is going to be the first of two videos for the review because it ends up being a little bit longer, so we definitely have to have two videos. So please make sure you watch video 8 and video 9. This is a review to help you guys get ready for our test over hypothesis tests and over intervals. So the first thing I want to go over is what confidence level means. So if we're 95% confident, just want to do a quick review over what 95% confident means. 95% confident means that if we repeated this procedure many times, then we would create many samples and many intervals. 95% of those intervals will contain the true value, whether it's a true proportion, p, or it's a true average, mu. But it's not about containing the sample proportion or the sample average, because those are already in the interval. Those are directly in the center of the interval. They were used to create the interval. So if there were many samples created, 95% of those confidence intervals will contain the true p or the true mu. The second idea that I want to quickly talk about is standard error. A lot of you guys are asking about standard error versus standard deviation. Remember, standard deviation is the best value that we want to use for a sampling distribution, but sometimes we have to resort to standard error. The concepts of them are exactly the same, but sometimes we have to resort to standard error. For example, if we're working with the difference of means, we have the standard error of the difference of means. Now, this does not mean standard error times the difference. This is standard error of the difference of means. So the formula for that is the square root of the first standard deviation squared divided by sample size, the second standard deviation squared divided by sample size. If you're working with the standard deviation of one sample mean, then you're talking about the standard deviation divided by the square root of the sample size. Very different formulas for difference or for a single. If we're working with proportions, the standard error of the difference between two sample proportions is the square root of the first p hat q hat divided by sample size plus the second p hat q hat divided by sample size. Okay? If you're working with a single proportion, the standard error of a single proportion is the square root of p hat times q hat divided by sample size. So these formulas with proportions kind of look the same. When you're working with means, they don't look the same at all. So you got to make sure you realize that. Also, this is the standard error for a interval for two proportions. If you're doing a test, you need to use a p hat and q hat pooled for both here and here. So be aware. We're going to talk a little bit about that later as well, but make sure you're aware of that. All right, the second thing we want to talk about is two-tail versus one-tail. So remember, let's just say that our null hypothesis is that we think the true average length of a pickle is 17 inches. An alternative is that we just care that it's different. We're concerned that the true average is different than 17. So that's when we use a not equal to sign, and that makes a two-tail. The only difference is whatever you get for your p-value, you double. So let's say that we do all the work and we get a z-score of, I don't know, 2.4. So if we actually go ahead and use that z-score to create a p-value, since that z-score is positive, we're going to look above it. So using normal CDF on our calculator, 2.4 to 99, we get a p-value of 0.0082. Now, because this was a two-tail, and it said that in the problem, we either said this directly or we inferred it, we're going to go ahead and have to multiply this by 2. It's as simple as just multiplying it by 2 on your calculator, and you get a p-value of 0.0164. And that is the p-value that we would be using to make our decision on rare or not rare. So that's really important that you guys realize that when it comes to two tails. All right, next thing we got to start looking at here, or the fourth topic I want to talk about in review, is how to get more power. Okay, remember, power of a test is your ability to detect a false null hypothesis. If a null hypothesis is false, you should be rejecting it. One way to get more power is a bigger sample size. Bigger sample size will always get you more power. So bigger sample size n. Make it bigger, you're going to have more power. Also, the more unusual something is, the more unusual an observation is, whether it's a p hat or an average, the more unusual your sample is, the more power you're going to have. So let's say that somebody told us that the null hypothesis was that the true proportion of people that wear seatbelts is 0.57, whatever. Then if I had a sample proportion of 0.59 versus a sample proportion of 0.65, which one of these would I have more power with? I'd have more power with this test right here because it is more unusual from what I thought was true. So more unusual means that I should see something more unusual. More unusual means I'm going to end up rejecting the null, and that's having power. With this right here, I might not have as much power. But again, bigger sample size will always work as well. Also, make sure you truly understand type 1 and type 2 error. Okay? Type 1 error, the null is true, but we accidentally reject it, making the error. Type 2 error, and that should be a Roman numeral number 2 when referring to error. Sorry about that. The null is false, but the error is we failed to reject it. So please make sure you understand that. So let's just look at an example real quick. Let's just say we have the P90X workout program, and we want to test if it's effective or not. So the null hypothesis would be that the program is not effective. That's what we would assume. The program is not effective whatsoever. The difference between maybe the before and after group was no difference. Versus the alternate, that the program causes weight loss. So it actually causes people to lose weight. Now, a type 1 error, the null is true. It's not effective, but we go with the alternative. We reject it, go with the alternative. So we use a program. We think it causes weight loss, but it doesn't really cause us to lose weight, so we're wasting our time. Type 2 error, the null is false. The program actually causes weight loss, but we fail to reject the null. So we don't even use the program because we think it doesn't work, but in reality, it really does work. So make sure you understand those two errors in that example as well. Okay, sixth thing I want to talk about here, and then we're going to have to take a break and go to the next video. Sixth thing to talk about here is how to lower margin of error. And my pen size got a little smaller right there all of a sudden. Margin of error. We'll make it better. Okay, so there's two ways to decrease margin of error. One that makes sense and one that doesn't, but both actually do decrease margin of error. The first way is to decrease your confidence. Now, that will cause you to have a smaller margin of error. Remember, if I decrease confidence, I'm going to have a smaller interval. Smaller interval, smaller margin of error. But decreasing confidence is not a good thing. It's not going to help us in the long run, obviously. So we don't really typically do that. The best way to decrease margin of error is increase sample size. Increasing your sample size will definitely cause you to have a smaller margin of error. All right. One last thing we're going to talk about here before we move on to video 9, because I've got to cut this video a little bit short, is the sampling distribution. In a sampling distribution, we're talking about what the many samples would look like. So let's say that somebody tells you that a sample showed that 47% of people wear a seatbelt, but somehow, some way, we know the true percentage is 52% of people that wear a seatbelt. Well, if we're going to be asked what the sampling distribution looks like, oh my goodness, use the truth. If you know the truth, use it. So the center of the sampling distribution would be 0.52, and the standard deviation would be using the truth. Don't ever use a sample if you think you know the truth. So it would be 0.52 times 0.48 divided by, I don't know, the sample size, let's say, is 100. That's what I would use right there for the sampling distribution. When would you use p-hat? If you're doing an interval. If you're making an interval, you would definitely have to use your p-hat and your p-hat only, because intervals are solely based on that. All right, so please make sure you watch video 9. It's going to be a follow-up. We're going to continue right away with topic number 8.